Hello everyone, this is Poorani. So far in the previous videos, we saw book sums from class 9 NCERT textbook, chapter 7 motion. In this video, we will see the first 5 sums given in the book back exercise, page number 85. This is the first sum. We'll go through the sum first. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? If you see, this sum is very similar to question number 2 given in page number 74. There we saw a farmer moving along a boundary of a square field. Instead of a square field, here we have a circular track. Otherwise, the sum is the same. So we will go to the sum. Well, the first thing we have is the diameter of the circle. The diameter is given to be 200 meters. From this we can find out the circumference of the circle. The circumference can be found out to be circumference is equal to 2 pi r, which can also be written as pi d. So the diameter here is 200, so the circumference is 2 pi meters. So the time taken by the athlete to complete this distance is given to be 40 seconds. So time is equal to 40 seconds. So from these two information we can find the speed of the athlete. Speed can be found out from the formula distance by time. So the distance is 200 pi and the time is 40 seconds. So the speed will be 5 pi meter per second. The speed is 5 pi meter per second. From this speed we can find out the distance covered. So the total time now, the total time the athlete runs is 2 minutes and 20 seconds, which is equal to 140 seconds. So from this total time we have to find the total distance. The total distance will be distance is equal to speed into time. The speed is 5 pi and the time is 140 seconds. So 5 into 22 by 7 into 140. This is equal to 2200 meters. So this is the distance covered in the given time, which is 2 minutes and 20 seconds. So we have to find the displacement now. So for finding the displacement, we have to find out how many times the athlete goes round the circle. So if we have to calculate that, so the distance he covers is 2200 meters divided by one circle, which is 200 pi, which is the circumference of the circle. So this is 2200 by 200 into 22, and we have 7 in the numerator. So this will be 100 into 7 by 200. This comes to be 3.5. So this 3.5, meaning 3.5 times he goes round the circle. Say we assume that the athlete starts from the point A, he goes one circle, this will be 1, again second time and third time he reaches A. When he reaches A again, his displacement will be 0. So we have 3.5, meaning he goes half of the circle. So he reaches this point B. From A he reaches the point B, which is the opposite side of the diameter. So now the displacement of the athlete will be the diameter of the circle, which is 200 meters. So the distance he is covered is 2200 meters and his displacement is 200 meters. This is the first sum. We will go to the next sum. The next sum reads, Joseph jogs from one end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds and then turns around and jogs 100 meters back to point C in another 1 minute. What are Joseph's average speeds and velocities in jogging? A from A to B and B from A to C. So we have two questions again. We will first draw a simple diagram. Say we will draw a straight line. Say this is point A, this is point B. The distance from point A to point B is 300 meters and the jogger turns back and comes back to point C. So the distance between B and C is 100 meters. So we have to calculate the speeds and velocities. So what do we have? The first thing we have is the distance from A to B. From A to B. The distance is 300 meters and the time is 2 minutes and 30 seconds. This is 150 seconds. So the speed will be distance by time, which is equal to 300 by 150, which is 2 meter per second. So what will be the displacement? Displacement will also be equal to 300 meters and the time again is 150 seconds. So the velocity is given by displacement by time, which is 300 by 150, again equal to 2 meter per second. In this case, we find that the velocity and the speed are both the same. So now from A to C, the second part of the question, A to C. What do we have? The distance will be the first 300 meters plus the 100 meter he jogs back. So this will be 400 meters. And the time is the first 150 seconds plus the 1 minute he takes to reach the point C. So this will be 150 plus 60. So which is 210 seconds. So the speed will be again distance by time, which is equal to 400 by 210, which is 40 by 21, which is approximately equal to 1.9 meter per second. This is the speed. Now for the velocity we have to find the displacement. So the displacement will be (300 minus 100) because the 100 meters he jogs from B to C is in the opposite direction. So the displacement will be 200 meters. So the time will be the same. Time will be 210 seconds. So the velocity will be displacement by time, which is 200 by 210 is approximately equal to 0.95 meters per second. So from this we see when the distance and displacement are the same, the speed and the velocity will be the same. When there is a difference in distance and displacement, the speed and the velocity will be different, because speed, velocity and displacement are dependent on the direction, while speed and distance are independent of direction. So we will go to the third question. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? To find this average speed, we have to first know the total distance travelled and the total time taken. So average speed can be calculated from total distance by total time taken. We will assume few things here. First, the distance from school to house or house to school. Let us assume the distance to be x meters. So now the time taken to reach school, let it be t1. So time taken to reach home, let this be t2. So this t1 will be equal to the distance x by the speed, which is 20 km per hour. t2 will be x by 30. So for finding this average speed, we have to know the total distance. Total distance will be is equal to x plus x, which is 2x, and the total time will be t1 plus t2, which is x by 20 plus x by 30. So when we divide these two, we get the average speed. This is equal to 2x by x by 20 plus x by 30. So 2x by 30x plus 20x by 600. So we have 2x by 50x into 600. So the average speed works out to be 24 km per hour. So this is the average speed of Abdul. So this is the next question, question number 4. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? We will write down whatever is given in the question. U is equal to 0. How do we have U is to be 0? Because the motorboat is starting from rest. So the acceleration is given to be 3 meter per second square and the time is 8 seconds. So now we have to find the distance travelled by the boat. For this we use the formula U is equal to AT UT plus half AT square. Half AT square. So your U here is 0 plus half into A is 3 and T is 8 square. So we have 64 into 3 by 2 which is equal to 96 meters. So this is the distance travelled by the boat in the given time of 8 seconds. So this sum, if you see, is very similar to the question number 4 in page number 83 which we solved in the previous video. Yes. So we will go to the last sum in this video. This is a graphical representation sum. We will read the sum. A driver of a car travelling at 52 km per hour applies the brakes. Shade the area on the graph that represents the distance travelled by the car during the period. The second part is which part of the graph represents uniform motion of the car. So here we have the graph. This graph we have taken velocity in the y-axis and time in the x-axis. Yes. So this if you see here, this point is 52 km per hour. So the car is traveling at this speed and at this, say at this time, at this particular point of the graph, the driver is applying brakes. So if we drop a straight line here, what do we have is this region of the graph will give you the distance travelled. This is the distance travelled by the car when the brake is being applied. So the next part, which part of the graph represents uniform motion? This square in the graph will represent the uniform motion of the car. So with this we come to the end of the video. We have solved 5 problems here. We will see the next 5 sums in the next video. Thanks for watching. Happy learning.